Hello, this is Detective Noah Green, NYPD Forensics, and this is my Terror at Lake Ogoki police report. First, I will review a brief lab summary, following lab error and improvements to help future detectives, then a proof of innocence for the innocent characters, and finally, conviction of the guilty suspect. Our task in Act 1 was to heat a calorimeter of water with the combustion of ethanol, isopropanol, and liquid paraffin. Post-lab, our task was to determine the accepted heat of combustion for these alcohols, then calculate the molar enthalpy for each character's vial. After that, we calculated a Hess's law equation that corresponds to the flammable liquid found on Harry's body. In Act 2, we measured the reaction time of sodium bicarbonate and other character substances to determine the rate of reaction. Afterwards, we measured the pH of each acid and applied our knowledge of acid equilibrium to calculate the concentrations at home. Finally, in Act 3, with the new information that Agaria had formed on Harry, we followed through with an experimentation of reactions between anions and cations, then anions and character acid samples, and that helped us target the guilty suspect. After calculations at home, we determined that because Josie had a precipitation at her volumes, she was guilty. Now, before I go on to explain the details of who's innocent, who's guilty, we have to consider lab errors and improvements that we can make to increase the accuracy. In Act 1, we noticed that there was a lot of inaccuracies. Errors included an open system, that is, the calorimeter not having a lid, and the buildup of soot as a byproduct from the incomplete combustion of ethanol, isopropanol, and lamp oil. I also noticed that the distance between the flame and the calorimeter must affect how much heat is reaching the water. There was also other uncertainties. Calorimeter was not perfect, and it will account for some heat loss in the end. In Act 2, there is abundance of human error. In order to measure 20 milliliters, the pipette must be used twice because of its 10 milliliter capacity, which means that there might be a little bit more introduced in the reaction. Also, we are relying on visual judgment of when the reaction ends. It's very hard to see at that small scale when the bubbles are fading away. There are also other mechanical uncertainties, such as the scale and the Vernier pH probe. However, I don't believe that this made much of a difference. In Act 3, we are relying on our personal judgment of the precipitate size. Additionally, the amounts expelled from the anion and ion bottles might have fluctuated and weren't totally accurate. The whole experiment was conducted in an open system. Temperature or pressure could manipulate the precipitate of the reaction as well. The following lab improvements could also prove helpful to increase accuracy for the next detective. For open systems, in Act 1, a lid on a can would make it a closed system. Also in Act 3, anions and cations mixed on a tube rather than a flat surface would reduce any manipulation from environment and effects in the reaction. When it comes to the calorimeter, in Act 1, distance between the flame and calorimeter should be reduced, so then there isn't any heat loss. When it comes to the pipette, in Act 2, a larger pipette with a capacity of 20 milliliters would also be helpful. Now I will explain the process I took to prove the innocence of the following characters. In order to prove a character guilty, the results must be close to Harry's. In Joanna's case, her molar enthalpy values are far less than Harry's. Therefore, she's ruled out and considered innocent in Act 1. Julian is considered innocent for a similar reason. His molar enthalpy values are much greater than the average other character compared to Harry's. In Act 3, when we are told that Harry has agaria and a white precipitate on his mouth, it means that the guilty suspect must have a presence of silver in their solution that results in a precipitation at their given volume. In Petra's case, she only has anions of calcium, iron, and magnesium present. Therefore, she has to be innocent. Similar to Petra, Michelle doesn't have any silver ions or white precipitate. In Intermission 2, when we were asked to calculate acid concentrations for each character, Michelle's turned out to be much less than Harry's, as you can see, 0.13, where Harry's is 0.18 moles per liter. Additionally, the reaction rate was far slower than Harry's as well, so we can cross out Michelle as a possible suspect. In Wally's case, in Act 1, his values were very close to Harry's. In Act 2, His reaction rate and acid concentration were the closest of any other suspect. But in Act 3, calculations prove that Wally could not be guilty because at that volume of metal, his Q is less than the KSP value for the reacting compound, which means that no precipitate forms. With no precipitate, the ingestion of his solution would not result in ageria or any white formation on the end of Harry's mouth. This subsequently proves that there's no way Wally could be guilty. Finally, in this section of the report, I will conclude why Josie should be convicted. At first, I thought that because of her reaction rates and acid concentrations not being close at all to Harry's values, she would be innocent. However, Josie's molar enthalpy values were the closest out of all suspects, and her silver nitrate results in a precipitate at the given volumes. As you can see in these calculations here for molar enthalpy, their values are quite close together. In this calculation, you can see that Q is greater than KSP, so therefore a precipitate forms. And given that ageria in the white precipitate in Harry's mouth is a byproduct of the silver nitrate in Josie's solution, we can conclude that she's guilty because her solution is the culprit of Harry's ageria. On behalf of NYPD, thank you very much.